This conversation is powered by Google Illuminate. Out illuminate.google.com for more. Welcome to this discussion on a fascinating tool for visualizing complex numbers. We'll be exploring the Complex Numbers Graphical Calculator, a project that offers a unique approach to understanding this often challenging mathematical concept.
Indeed. Visualizing complex numbers can significantly improve comprehension, moving beyond abstract algebraic manipulations.
Exactly. It's not just about calculations, it's about grasping the geometric interpretations. What are some of the key features of this calculator that facilitate this understanding?
The calculator cleverly uses graphical representations of operations like addition, subtraction, multiplication, and division, making the often abstract concepts more intuitive.
And how does it handle the geometric representation of complex numbers themselves?
The calculator represents complex numbers in the complex plane, with the real part on the x-axis and the imaginary part on the y-axis. This allows for a direct visual representation of each number as a point or vector.
So instead of just seeing 2 plus 3i, you see a point plotted at coordinates 2, 3?
Precisely. This visual representation immediately clarifies the magnitude and argument angle of the complex number.
Let's talk about the operations. How does the calculator visually demonstrate addition and subtraction?
Addition is shown using the parallelogram rule, where the sum of two complex numbers is represented by the diagonal of the parallelogram formed by the two vectors representing the individual numbers. Subtraction is simply the reverse of addition, visually represented as the vector pointing from the subtrahend to the minuend.
That's a very clear way to illustrate those operations. What about multiplication and division?
Multiplication is visualized by multiplying the magnitudes and adding the arguments. The calculator shows this as a rotation and scaling of the vectors. Division is the inverse, showing a scaling and rotation in the opposite direction.
The document mentions several other important concepts. Can you elaborate on the significance of the unit circle and the triangle inequality?
The unit circle, z equals 1, is crucial because it represents all complex numbers with a magnitude of 1. It's fundamental to understanding rotations and the polar form of complex numbers. The triangle inequality, z plus wa, provides a geometric constraint on the sum of two complex numbers, showing that the magnitude of the sum is always less than or equal to the sum of the magnitudes.
And what about the concept of conjugates?
The conjugate of a complex number is its reflection across the real axis. The calculator likely shows this visually, highlighting the relationship between a complex number and its conjugate. This is important for various operations and simplifying expressions.
The document also includes algebraic rules for multiplication and division. How do these relate to the graphical representations?
The algebraic rules provide the computational framework, while the graphical representations offer an intuitive understanding of the results. For example, the algebraic rule for multiplication shows the result of multiplying two complex numbers, while the graphical representation shows the geometric interpretation of that result as a rotation and scaling.
Beyond the visualization, what are some practical applications of this calculator?
This type of tool is invaluable for students learning complex numbers. It helps bridge the gap between abstract algebra and concrete geometric understanding. It can also be useful for engineers and scientists working with complex numbers in various fields.
Are there any limitations to this graphical calculator or areas for potential improvement?
While the current version is quite effective, future versions could incorporate more advanced features, such as interactive manipulation of complex numbers and the ability to visualize more complex functions of complex variables. Improved user interface design could also enhance usability.
This discussion has been enlightening. The Complex Numbers Graphical Calculator seems to be a powerful tool for making a challenging topic more accessible and intuitive. Thank you for sharing your expertise.
My pleasure. Visualizing mathematics is key to deeper understanding, and this calculator is a great example of that principle in action.
As a great discussion.